Chapter 11, Normal Distribution. The standard normal probability distribution is describing a set of data. If you collect a set of data and then you plot the data into a histogram, if your histogram fall under the general shape of this curve, that means your histogram is symmetrical and it's a bell-shaped curve. Okay, then we consider the set of data is normal. So often enough, a lot of our data in the world it does have this characteristic. When you collect enough data, you should see your histogram of the data look like a bell shape. Okay, so what do we know about this? The center of your histogram or center of this curve is where the mean will equal to the median equal to the mode. And it also tell you, like for example, looking at these three normal distribution curve here, the one in the middle, and they all have the same mean, median, and mode because they all share the centers, the peak, right, of the curve is all the same, except the spread. So the middle one, the one that's highest here, has the lowest standard deviation because the spread of the data is the least amount, versus the one out here, right here. This one standard deviation equal to 7. Look how spread out this data is. Now, empirical rule, 68, 95, 99.7 rule. This rule or these numbers will never change. Now, what are these numbers? So let me give you an example. Remember the example from the peanut butter jars that we bought. So if you grab this onto a histogram, okay, so you find the average. But by the way, the average of these numbers is 3.68. So average goes in the middle. Now, if anybody provide you that say the data is normal, in this case the data is normal, the first thing you do is draw a curve, okay, your normal curve, and then you right in the middle put average, the mean 3.68. There it is. Now then you draw 3 lines to the right and 3 lines to the left. Then each space is 1 standard deviation. So for example, 368 plus 0.26. That's how you get 3.94, plus another 0.26, plus another 0.26. On the left side, you minus 0.26, minus 0.26, minus 0.26. Now, after you find all these dollar values, according to the empirical rule, the 68, 95, 99.7 rule, we can easily estimate we can estimate all the peanut butter jars like that we collected the data, even without looking at the data. As long as I have the mean and the standard deviation, and I can construct this bell-shaped curve, then I can conclude that approximately 68% of the peanut butter that sample we collected was between $3.42 and 3.94. And 95% is between 3.16 and 4.20, and 99.7% is between 2.9 and 4.46. So the 68, 95, 99.7 rule represent 68% is the first standard deviation apart. 95% of data should fall between the -2 and +2 standard deviation. And last number is the -3 and the 3 standard deviation from the average. Now, learning what a z-score is. So z-score, also known as a normal score, we use it to help us compare two different values with a scale, different scales. For example, okay, how would you compare two scores like this? For example, a student Pat was done taking midterms. She received an 82 on her statistics exam, and the mean grade for that test is 74, standard deviation is 12. Another test, she received a 72 on biology test. Okay, the mean for that test is 65 and standard deviation is 10. Then she has a kayaking exam. She got a 91. The mean score is 88 and standard deviation is 6. Now, how do we know which test is relatively better? That means how is she doing compared to the rest of the class, basically. Like which one is relatively better. So the only way to compare is you can't really compare score to score because we don't know what's it out of. We don't know anything about it. Except, well, if we have mean and standard deviation, we can use z-score means where is your score, how far away from the average, how many standard deviation away from average, either below or above. So if you look at statistics, the formula says take your score, your data, minus the mean divided by standard deviation. So for statistic, she scored 82. The mean of the test was 74, and standard deviation was 12. For biology, she scored 72 minus the average divided by standard deviation. Kayaking is 91 minus the mean or the average divided by the standard deviation. When you do that, this number is the best because biology test was 0.7 above average, above the mean. Right, 0.7 was standard deviation above. All the other two, they all above. Okay, they all better than average, but this one is the best. Okay. The mean score on a test for statistics was 82, with the standard deviation is 7. If a grade A is 93 point, what is the z-score for A, right? So if A is 93, it's just converting. We'll just do this again. So 93 minus 82 divided by 7. So the z-score will be 1.57. The density curve or normal distribution. Okay. Now we're looking at the z-score and the areas. So basically what we're saying is this. If we look at our normal curve, okay, and then say you want to have a certain value, and then we want to say there's area, how much area is below the certain value. Another interpretation of the area is what's the probability of getting a number that's less than that designated number. Okay, so let's put that to practice a little bit, see how there's another application of this. Okay, so we use the peanut butter thing again. Then we want to know, so we have the mean and the standard deviation. Okay, it's given here again. We're saying what's the area for the peanut butter. So say they have for the peanut butter jar that contain less than $3. So if you look at our peanut butter example here, so $3 will be somewhere here, right? A little bit to the left of 3.16. We want to know how much area is to the left of that. Not a lot, okay, but how much area is that? Okay, so well, can we figure that out? Okay, so probability of that area is less than 3. So what we need to do is we change that 3 to change it to z-score. So take that number minus mean divided by standard deviation like before. Then the number is negative 2.615. Now, what do? You need to look up the value in the normal table. Now, the normal table is located in the back of your textbook. Or I also place a link to it on your assignments. So, okay, our number is negative 2.615. So negative 2.615. So here's a table. This is what it looked like. So negative 2.165. So negative 2.6 right here. Okay, 615. Now we don't have 15 here, so we can round it to either 62. So negative 2.62. So the answer is negative 2.6, and then 2 is right here. So approximately, if you look at where negative 2.6 and the 2 is, this is the last digit. It's somewhere here, 0.00440. Now, if you want to be more technical about it, you be the number between these two numbers, because the actual number is actually negative 2615. So got to be between these two numbers. Okay, and that's how you use this table. So if you look at the number, there it is, 0.0044. Okay, and that's how much area. It's not a lot, right? It's not a lot. Okay, now remember, area under the curve is equal to 1, so this is not a big number. Okay, how about the area to the right, more than 4.25? Now we do the same thing. We take our data minus the mean divided by standard deviation. You get 2.19. But this table here, this table only tells you to the left, okay, of the table of the area. But when you say you want something more than 4.25, if you think about your graph, here's more than 4.25, so somewhere here, right? More than is on this side, so it's not to the left, it's actually to the right. So if you use this table, you only tell you what's to the left, not to the right. So what you want to do is use the idea of a complement. Okay, so you have to do 1 minus. So you look up 2.19 first. That's this value in the table. Then, because this is how much area to the left, 98%, right? But that's not what we have. We have a very little area. So 1 minus that, that's what you have, 0.0143. Now, if you want to find something in between, what's the area in between these two numbers? Well, you do the z value, you come with the z, right? And this one we found earlier. Okay, now you just look up both of these values. You look up this value, you get this, you get this value. Now remember, you're looking for area. It can be negative, so always a bigger number minus a small number. Then you get a positive number, 98%. So in conclusion, anything that's less than, you just look it up. If it's more than, you have to look it up, but 1 minus whatever you look up. If it's in between two values, you just look up both of these. Now these values, you have to convert them first, right? The first step is always taking whatever this value, you have to subtract the mean divided by standard deviation. So in between, after you convert it, then look up both of these numbers and then take the big number minus small number. Then you get the area in between. Now we can easily change these three questions into saying, well, it's the same computer area. We will say, find the probability of the peanut butter that's cost less than 3. We'll say this question will be, find the probability of the peanut butter jar that costs more than 4.25. Or we can say this one as, find the probability of peanut butter jar that's between $3 and $4.25. Okay, so that's what this is. So area and probability is the same answer. So these three examples is what we just talked about. Instead of say finding area, we say finding the probability. Finding the probability. These three are the exact same question, except we're now changing back to what a statistical question would sound like. Okay, so at this right here, this example here, it's another practice using the table, but instead of saying less than, greater than, we use mathematical symbol. Look, this is less than, right? Okay, so if it's less than, you just look it up. If it's greater than, you have to look it up first and then 1 minus. If it's in between, you look up this value, you look up the bigger value first, and look up the smaller value, and you subtract each other. Look it up only, 1 minus whatever you look up both values and subtract. And that's how you find the probability. Okay, so let's take a look at this question here. A statistics instructor obtained heights of her 35 students. Luckily, the heights are normally distributed with a mean and standard deviation. Okay, so we got this. What's the probability one of her students have the height 60 inch or more? So probability of x greater than 60. Okay, then remember we cannot look up 60. If you notice in the table, if you go to the table, there's no 60 anywhere. Okay, so if you look, there's no 60 anywhere because we have to convert them into z value. It's a z table, normal table. So once you do your z score, take your number minus mean divided by standard deviation, you see you find your value. Then since this number is to the right or greater than, you have to do 1 minus and look up 0.87, negative 0.87 on the z table. Then you will get your number. This when you look up the table, you get 0.1922. Then 1 minus that will get you the value that you desired.